Electricity is a flow of charged particles. These particles originate in the atom. If you have ever studied the atom, you will know that an atom has a compact center called the nucleus. The nucleus contains two types of particles: protons, which have a positive electric charge, and neutrons, which have no electric charge. Small charged particles called electrons exist outside of the nucleus. Electrons have a negative charge and they are attracted to the positively charged protons. The electrons move in high-speed orbits around the nucleus, held close to the nucleus by the strong force of attraction from the protons. You can witness this force by rubbing a balloon on fabric, creating an imbalance of electrons and protons. Small pieces of paper will stand up and jump to the negatively charged balloon. Scientists call this static electricity because the charge doesn't move, it stays on the balloon. Two negatively charged balloons repel one another. The like charges on each balloon repel. This force can cause electrons to move from one place to another. When electrons flow between 2 points, we call this electricity. One of the most dramatic effects of electricity is a lightning strike. Electrically charged clouds release their charge in an explosive flash. A powerful demonstration of electricity. To use electricity, we need to find a way to safely contain and control this flow of charged particles. That is what a battery cell does. A battery is a chemical device capable of converting stored chemical energy into electrical energy. As you know, batteries have two terminals or ends labeled plus and minus. This reflects the negative and positive charges on electrons and protons. The chemistry of a battery creates a force that moves electrons out of the metal plate on the negative end and attracts them to the metal bump on the positive end. Electrons will start to move from minus to plus if the right kind of material is connected to the battery. Materials that allow electricity to travel through them are called conductors. Most metals are good conductors of electricity. Copper is the most common metal used in wires. In this animation, a conductor is connected to each terminal of a battery. Electrons start to move, traveling from the negative terminal towards the positive terminal. This is electricity. The electrons actually move from atom to atom as they travel through the conductor. This is a safety warning. Never connect a short metal wire between the terminals of a battery. This is a short circuit. The wire will get hot, you might burn yourself, and the battery will quickly lose its energy. Have you noticed the letter V on the side of a battery? This represents volts. Volts, or voltage, is a measure of the force moving the electrons. A AA battery is usually 1.5 volts. This is a low voltage, and that is why it is safe to handle a AA battery. Higher voltages are dangerous. Never experiment with anything that plugs into a wall outlet. Wall outlet voltages range from 120 volts to 240 volts. Extremely dangerous. Here is an example of a low voltage battery being used to create some light. Connecting a light bulb to this battery, we have created a circuit, a path for electrons to travel on. Our light bulb does two things. It introduces some resistance into the circuit, reducing the flow of electrons so that the copper wires won't get hot, and it converts electrical energy into light energy. Our circuit also demonstrates a switch, a device for turning the electricity off and on. The switch does this by creating an opening in the circuit. This is an actual circuit similar to the one in the animation. The wires I am using have metal alligator clips connected to their ends, making it easy to connect. The metal in these wires is covered in plastic. Plastic is an electrical insulator. The current from our low voltage battery will not flow through the plastic, but easily travels in the copper wire under the plastic. Connecting and disconnecting the wire creates a simple switch, turning the light off and on. wall switch does the same thing. The plastic lever and cover plate protect you from the high voltage used in this circuit. It is possible to construct circuits with 2 or more bulbs. Here is one example. The 2 bulbs in this circuit are connected in parallel. If we follow 2 electrons traveling through this circuit, we see there are 2 possible paths. One electron leaves the negative terminal of the battery and travels through the upper bulb, the other through the lower bulb. They both end at the positive terminal of the battery. Parallel circuits always provide more than one path for the electricity to travel on. If you are in a room with a row of ceiling lights, these lights will be connected in parallel. One advantage of connecting lights in parallel is that if one light is removed or fails, the other lights will not be affected. Removing one light from this circuit does not affect the other light. It remains connected to the battery. This is a parallel circuit. Notice when I disconnect one bulb, the other one stays on. It is possible to build parallel circuits with many branches. This circuit also has 2 bulbs, but notice there is only one path. This is a series circuit. All electrons travel from minus to plus following the same path. If one of these lights is removed or fails, the circuit is broken and the other light will go out. Lighting systems are rarely wired in series. This is a series circuit. Notice when I disconnect one bulb, the other one goes out. Switches are wired in series with the loads they control. In this example, our lights are the loads, and this circuit contains a series and parallel component. The switch is in series with the parallel branches. This is how one switch controls many lights in a room. Series and parallel circuits can be found in all electrical and electronic devices. The wiring in your home is a combination of series and parallel circuits. This motherboard of a computer consists of a maze of series and parallel circuits connected to control the electronic components that allow the computer to function. If you are interested in learning more about electricity and electronics, science and hobby supply retailers often have battery-operated electronics experimenters kits designed to let you safely learn about electricity. More science and technology-related videos can be found at our website, hylaroad.com. Follow the videos link.